So, guys, welcome back to Aerominds Training Center. We are now starting with the part two of Aero overview and definitions, which is the chapter one. So, in the last chapter, we did the basic requirements of aircraft and the forces of with the forces which are acting on an aircraft. So, now we'll talk about the air properties and aircraft performance. So, we'll start. Now, as we know, air is not constant. uh, this is a very common beginner mistake. Many students assume air is the same everywhere, but it is not. Air properties change with your altitude, and but what happens as you go higher, the air pressure changes and the temperature changes. Now, pressure reduces with altitude, temperature generally reduces with altitude in the troposphere. Now, these changes affect how much lift is produced. Okay, your pressure, your temperature, your density basically changes your air. So what happens, they affect your air. Now these changes will affect how much lift is going to be produced. It is going to change how much thrust will be available for flying, then how much drag acts on an aircraft. Now, understanding these variations is essential for a complete understanding of the principles of flight. This is why meteorology and POF are connected subjects. DGC expects you to understand how the basically they want you to understand how the air behaves, air's behavior over the aircraft's performance. Okay, so remember, air is not constant. The properties change with altitude, such as the density, the pressure, and the temperature. So remember, the density reduces as we go up because the molecules are less, then pressure also reduces and temperature also reduces, but in the troposphere. Now, understanding these variations are completely are important for complete understanding. Okay, now we come to an extremely important concept which is called aircraft design as a compromise. Now, aircraft design is never about perfection. Okay, it is more about a balance, carefully balanced compromise. Now, improving one aspect often reduces efficiency in another aspect. Okay, for example, if you want to increase your lift by changing your wing shape, you may also increase your drag. Now, if you reduce your drag, you may reduce your stability, and if you increase your strength, you may basically increase your weight. So that is it. So designer always makes some compromises. There is no perfect design. There is only the most suitable design for a given role, for a given purpose. Now suppose a fighter aircraft, what happens in a fighter aircraft and a suppose a passenger aircraft cannot have the same design priorities. So remember this for your own knowledge and also for the exam, obviously. So aircraft design is carefully balanced compromise because improving one aspect often reduces the efficiency in another aspect. One example is increasing lift may increase the drag, and one more example, increasing the strength might increase your weight. So remember, there is no perfect design, only the most suitable design for a given role. Got it? Finally, we'll talk about the direction of motion and versus the direction of pointing. So what this means, unlike a car on a road, an aeroplane does not grip the air. The car's tire grip the road. So the direction of the car is pointing in the direction in which it is moving. An aircraft moves inside like inside a fluid, which is air. Like air moves, flows, and changes the direction. Okay, now because of this, what happens, an aircraft is often not pointing in the exact direction. uh, the nose of the aircraft may point towards slightly left or right or up or down depending on the wind or the airflow. So we'll see a diagram in which you can understand this. So like this, suppose the aircraft wanted to go from departure to destination. The aircraft took off from here, and this was the planned route, but the winds are coming from the left side, so the aircraft drifted, but the nose is pointing in the direction of the destination, but the aircraft has drifted. So this is the track now in which the aircraft is moving, and this is the heading of the aircraft. So this is the heading, this is the track, this is the drift angle. So remember it. Now, what happens now, if you see, this concept is important. Now why? Because understanding the angle of attack, drift, or the relative airflow. Angle of attack is the angle between the wing chord line and the airflow. So about chord line and airflow, we'll read about these values, these things in the next chapter. Okay. Now drift occurs because the wind is pushing the aircraft sideways. This is the reason for the drift. So what happens? Relative airflow is the direction of the air relative to the aircraft and not the direction of the nose. So remember, the relative airflow is the direction of air which is relative to the to the aircraft. Okay, to the aircraft and not the direction of the nose. Now we'll mark. So unlike a road, an aeroplane does not grip the air, so it is often not pointing in the exact direction in which it is moving. Now this concept is important for understanding for of the angle of attack, then the drift, and also the relative airflow. Okay, so now we'll move to the physical definitions. So first is mass. We'll start with mass. Now mass is measured in kilograms. Okay, which we write as kg, kilogram, kg. Now mass means the quantity of matter in a body. Okay, mass means the quantity of matter in a body. Now if we put this in simple words, mass tells us how much stuff is present in something, how much stuff is present in something. Okay, an aircraft, for example, has large mass because it is made up of lot of materials, metals, fuel, passenger, cargo, system, etc., etc. Okay, but there is a more important way to understand mass, especially for aviation. Now, mass is a measure of how difficult it is to start, stop, or change the motion of a body. Okay, it is very important for the understanding. Heavier aircraft does not like to change what it is already doing. Now, if it is standing still on the apron, suppose it is standing still on the apron, it does not want to move. It will resist starting to move. And if it is moving very fast, suppose on the runway, it will resist stopping. Now, if the aircraft is flying straight, it will resist changing the direction. You can remember it like that. Now, here, when we say the word body, the word body, it does not mean a human body. He body means any substance which the rules apply to. Okay, now body means any substance. It can be a solid, it can be any aircraft or anything. It can be a liquid like a fuel, it can be solid like an aircraft, it can be gas like air. Everything that exists has mass. Okay, that's all. Remember, body means any substance, solid, liquid, or gas. Now we'll understand the key ideas which are related to mass. So the larger the mass, the greater the force required to start or stop it over the same distance. Okay, start or stop over the same distance. Now this is why a small car can stop easily. Suppose you are driving a small car like a Mini Cooper, it will stop easily. But on the other side, when you are driving a large truck, it needs a longer distance to stop. And that is why in aviation, this is why the heavier aircrafts need a longer runway for takeoff and landing. Got it? Now, next is mass strongly influences the time or the distance which is needed to change the direction of motion. Okay, now what this means, if an aircraft has a large mass, it will not turn quickly. It will take more time and more space to change the direction. Okay, this is why large aircrafts feel smooth but not very agile. Okay, while small aircrafts feel more responsive. So now for reference, we'll see an image. So you can see in this, the matter inside this body, which is standing on the earth, has some, so it will have mass. Okay. So that mass is the force. Then how much matter is inside a body is known as the mass. How much stuff is in it. So that is it. So we'll mark in this The remember the unit, which is kilogram, the definition, which is the quantity of matter in a body, how much matter it is having. Then it is a measure of how difficult it is to start, stop, or change the motion of a body. Okay, here the term body means any substance, liquid, solid, or gas. Gas can be air, liquid can be fuel, and solid can be an aircraft or a person. Now, the key points. So, the larger the mass, the greater the force required to stop it, or over the distance, over the same distance. Okay. Now, mass strongly influences the time or distance which is needed to change the direction of motion. I have already explained it to you. So, we'll now move it to force. So force is the unit for force. The force is measured in newtons. Remember, okay, it is measured in newtons, which is written as n newtons. So a force is a push or a pull that causes or tends to cause a change in the motion of a body. Okay. Now notice the words causes or tends to cause. Even if motion does not actually change, the force still exists. Okay, tends to cause or it causes. Okay, now for example, suppose when an aircraft is cruising in straight and level. So straight and level means it is flying in the same direction with the same speed and everything. So that is straight and level. The lift and the weight is equal. In a straight and level flight, the lift and weight will be equal. The aircraft is not climbing and it is not descending also. So both are same. So what happens? And the thrust and drag will be equal, the weight and lift will be equal, so the motion does not change, but the forces are still acting on it. Okay, now an important note here is that in flight an aircraft is acted upon by four forces, each pushing or pulling in different directions. Now we have already discussed them: the lift, drag, weight, and thrust. DGCA loves to test whether you understand these forces or not, and these are not the movements. So remember, the definition is: a force is a push or a pull that causes or tends to cause a change in the motion of a body. Simply, you can remember it like a push or a pull. Now remember, in flight, an aircraft is acted upon by four forces, which are act pulling or pushing the aircraft. Now, if you want to see the reference image for this, so this is it. Now, for force, pushing or pulling, a push or a pull is called force. Now next we move on to is weight. Now we'll talk about weight. So weight is basically measured in newton. Now if you ask why, we always measure weight in kgs, but that is not actually weight, that is mass. So since weight is a force, we measure it in newton. Okay, now this is very important. Many students are making mistakes here. Weight is due to the force of gravity acting on the mass, or acting on a mass. Mass is how much matter you have, and weight is how strongly the gravity is pulling you. Okay, so mass is the matter and weight is the force which the gravity is pulling you. Now the force for weight is the force equals mass multiplied by g. We write it as F equals m into g. So here the m is the mass, the which is in kilograms. The g is the acceleration due to gravity, which is 9.8. On Earth, the g's value is approximately 9.81 meter per second squared. Okay. Now this means that a mass of 1 kg weighs 9.81 newtons on Earth. Okay. On any other planet, the mass would be the same, but the weight will be different because gravity would be different. Remember this. You must have studied in your school this thing, but you guys can remember it for your concept in the theory questions. Now we'll look at an example. So first we'll mark this. So weight is newton, the unit is newton, definition is the force due to gravity, then the formula is F is equal to m into g, then where mass is the m, which is in kg, g is acceleration due to gravity, which is 9.81 meter per second square on the earth. So A 1 kg mass weighs 9.81 newtons on the earth. Remember. Now we'll do an example. Now suppose the mass of a Boeing 737 aircraft is 60,000 kgs. 60,000 kgs. So, to find its weight, what we'll do? We'll basically multiply the mass by the gravity. So, 60,000 multiplied by 9.81 will give you 5,88,600 newtons. So, therefore, 5,88,600 newtons of lift must be generated for a level flight. Okay, this means the level flight will be generated at this exact value to balance, which will balance the weight of the aircraft. Now, if the lift will be is less than this, the aircraft will start to descend. Okay, and if the lift is more, the aircraft will start to climb. Now this example helps you to connect the numbers with the real aircraft. Okay, uh, so suppose this is the mass. If you want to find the required lift, multiplied by 9.81, you'll get in newtons, because it is the unit for lift. Then this is the answer, so remember it. Now we move to the center of gravity, which is extremely important for pilots. Now the center of gravity, or also known as CG, is basically the point through which the total weight of the aircraft acts. So remember this. Okay, it is the point through which the total weight of the aircraft acts. Okay, imagine, you can imagine it as a balance point of the aircraft. If you could support the aircraft exactly at this point, it would balance. Suppose if you can balance a pen on your finger. Now if you put your finger at the CG of the pen, so you can balance the pen. So in the same manner, you can imagine an aircraft with the CG. Now, an aircraft in flight is considered to rotate about its CG. This means when the aircraft pitches, rolls, or yaws, it rotates around that point. This is why the CG location affects the stability and control. We'll read it in the further chapters. So, the center of gravity is the point through which the total weight of the aircraft acts. Okay, and the key points are basically an aircraft in flight is considered to rotate about its CG. Now remember, the center of gravity must remain within the specified limits. Specified. So there are two limits: the forward limit and the aft limit. Okay, the CG must maintain itself between these two values, these two limits, because the forward means the which is towards the nose, and aft means which is towards the tail. Now these limits are given by the manufacturer and they are approved by some authorities, so they are of great consideration. Now, if the CG is outside the limit, the aircraft may become unstable or uncontrollable also. Now, if the CG is too far forward, what will happen? The aircraft may be very difficult to stable, but difficult to rotate, or it might be very stable, but it will be very difficult to rotate or flare the aircraft during landing. But if the CG is too aft, the aircraft may become very unstable and dangerously sensitive. And this is why loading and weight balance are critical in aviation, because you can change the CG of your aircraft by increasing the weight or decreasing the weight. So remember, the CG must maintain within specified forward and aft limits for stability and for control. Got it? Now let us talk about. So we will see the image for the CG. So this image for was for your weight, and now we'll see the CG. So this is the CG. This is where the lift and the weight acts. Okay. Now we'll move to work. So work is basically the unit. Work is measured in joules. So remember, work is measured in joules. It is written as J. A force is said to do work when it moves a body in the direction in which the force acts. Okay, this sentence is very important. So listen carefully. Now, if a force is applied but no movement occurs, so no work is done. For example, if you are pushing a wall with all your strength, but the wall does not move, you are tired. But from the physics point of view, no work will be done. Now, the formula for the work is force multiplied by the distance. The work equals force into distance. Now if a force of suppose 10 newtons moves the body 2 meters, then the work done will be 10 newtons multiplied by 2, which will give you 20 newton meters. Okay, now that will be the work done. A newton meter is also known as is also called joule. So 20 newton meters is 20 joules. Now this concept is used later when we talk about engines and performance. So newton meter is also called joule. So remember, uh, a force is said to do work when it moves the body in the direction in which the force acts. The work is done when there is movement in the direction of the force applied. So if a force is applied but no movement occurs, so no work will be done. Then comes formula. So work is equal to force into distance. Now, if you see an example, as I told you, 10 Newton moves the body for 2 meters. The work will be 20 Newton meters. A Newton meter is called also a joule. Now we move to power. So power is measured in watts. These are actually just physical terms which you have to memorize, uh, which can help you, but it's mainly for memorizing it. So what you have to do, you just have to mug up these things. Now comes the definition. So definition is basically so see, watt first, it is written as W. Remember, for work, it is joule, which is written as J. So don't confuse it. Watt is W for power. So the definition, power is the rate of doing work. That is how fast work is done. Okay, in simple words, power basically tells us how fast work can be done. Okay, doing the same work quickly requires more power. Doing it slowly requires less power. Okay, the formula for power is work divided by time, work upon time. So force into distance is basically work, so work upon time. Okay, so remember this. So power is equal to force into distance, which is work upon time. Now see an example. Um Suppose a force of 10 newtons moves a mass 2 meters in 5 seconds. Then what will be the work done? So simply you will multiply the force of 10 newtons into 2 divided by 5, and you will get 4 joules per second. That is watt. 1 joule per second is also known as 1 watt. So the power used is 4 watts. Okay, 1 joule is per second is 1 watt. So the power used is 4 watt. And in aviation, the engine power tells us how fast work can be done to move the aircraft. Now we come to energy. So energy is measured in joules. So unit is joules. Then energy is the ability to do the work. Remember, it is the ability to do the work. If something has energy, it means it has the potential to cause a movement. Now the move amount of energy a body has is measured by the amount of work it can do. Now, since work is measured in joules, energy is also measured in joules. This keeps the system consistent. So remember it. Okay. Now remember, the amount of energy a body has is measured by the amount of work it can do. All and since work is measured in joules, energy is also measured in joules because it is the amount of work. Now we'll move to the kinetic energy. So which is extremely important for flight actually. Now see, kinetic energy is actually the energy which is possessed by a body due to the virtue of its motion. You must have heard it. Now if something is moving, it will have kinetic energy. That is it. A moving mass can do work when it is brought to rest. A moving mass can do work when it is brought to rest. And for example, moving air can push on a wing. A moving aircraft can cause damage if it hits something or if it hits a person standing. Now, the formula for kinetic energy is Ke is equal to half mv square. Okay, so the unit is joule. Definition is kinetic energy is the energy which is possessed by a mass due to its motion. A moving mass can do work when it is brought to rest, and the formula then, which is half mv square. Then comes the example. So suppose we have 1 kilogram of air. Okay, we have 1 kilogram of air which is moving at 52 meters per second, which is around 100 knots. Now we calculate kinetic energy as zero point 0.5 multiplied by 1 multiplied by 552 squared. Okay, this gives us 1352 joules. Okay, this means that the moving air possesses 1352 joules of kinetic energy. This is extremely important because lift depends on how kinetic energy of the air is flowing over the wing. Okay, so remember this example, half 1 kg of air at 52 meters per second. So half into m into v square. Now air possesses 1352 joules of kinetic energy. Now comes an important concept which DGCA loves. So if you double the velocity, kinetic energy increases by 4 times. This is because the velocity is squared in the formula. Okay, mass is not squared, the velocity is squared. This means the speed has a much greater effect on the kinetic energy than the mass as compared to the mass. Okay, now this is why speed is so critical in aviation. A small increase in speeds can produce large increase in lift. Now this is why the takeoff speed, stall speed, approach speed, everything is so important. So doubling the velocity increases the kinetic energy by 4 times. Velocity has much greater effect on the kinetic energy than mass because velocity is squared. Got it? Now, if you clearly understand these terms of mass, force, weight, everything else, then the principles of flight sub syllabus, it will stop feeling like theory, okay, and start feeling more logical. These concepts will come again and again, so make sure they are very clear in your mind. So that is it for the part two. From the part three, we'll start doing Newton's first law of motion. So that is it for the part two. See you in the part three. Okay, take care.